In this video, we are going to look at Lesson 3, Practice Problem 4, Minimums and Maximums. However, we are only going to be looking at Part 4 and Part 5 of this problem. So here in Part 4, we are given a fixed cost for each of these packages. So what this is saying is that a company only has to pay this fixed cost if they sell one or more of the given packages. So here are the numbers that were given to us in part 1, and then here are the fixed costs that were just given to us. So let's go ahead and solve this. First, we'll add a quantity column, and these are going to be our decision variables because we want to know how many packages we need to sell to maximize profit. The next column we're going to add is called a binaries column. And let me use the format painter here. And let me put some dummy values in this quantity column. And so this binaries column, this is going to tell us whether or not the fixed cost gets applied. So 1 means yes, apply the cost. A 0 means no, do not apply the cost. So if you are familiar with Excel, your intuition here might tell you to use an if function. So for example, you might say if this value is greater than 0, place a 1 here. If not, place a 0. Okay, so normally this would work in Excel. However, Solver does not like the if function, especially when the if function references a decision variable. So for this reason, we are not going to be using an if function. Instead, we are going to add another column. Let's call this linking constraint. We'll auto size this. And then give it some borders. And actually, we're going to get some more room here. Okay, so linking constraints. And we're also going to have an M value. And remember the M value, this is really just a big number. So for this problem, we're going to use an M of 1000. Okay, so for the linking constraints formula, really this formula is from the video lessons. I'm just using the same logic that was given to us. We're going to take this formula, go equals quantity minus this binaries times this M value, and we're going to lock it, put the dollar signs around it. Then we'll copy this down, and because this is a constraint, I'm going to use the green color to let us know. Okay. And so we also have some other constraints here for labor and balloons. So I'm going to create another table down here, copy and paste these, change these labels to labor used and balloons used. Then down here, total used and available. These will be our constraints. All right, so for these numbers, we're going to delete these. And then for labor used, we're going to do labor required times, we want to multiply it by the quantity returned for the packages. So as we copy this formula down, as we copy this formula across, we want this number to stay here. We want this cell to stay here. So we are going to put a $sign in front of the H. So as we copy this, okay, so that's doing what we want to do. And then total used, we'll go sum here, and then available, these are the constraints that were given to us, and the number for labor is 500, and for balloons it's 360. And because these are constraints, we'll put these in green. Okay, so now let's come up here. We'll put variable cost, fixed cost, revenue, and then profit. Okay, variable cost, sum product, and then our decision variables, fixed cost, take this times our binaries, revenue will be sum product sell price times quantity, and then profit equals revenue minus sum of our cost. So we'll bold all of these. We'll put this number in red, and we'll give it $signs. Okay, so now we're ready to use solver. Come up here to data, solver. We want to maximize our profit by changing our decision variables will be our quantities here plus our binaries, don't forget that. And then for constraints, we want to make sure we follow the available balloons and labor constraints, so less than or equal to these numbers. Add, and then these are our binaries, so we have to change this to binary, binary, add, and then our linking constraint, we'll highlight those, and that's going to be less than or equal to 0. Okay. So that should be all of our constraints. Go to simplex and solve. Okay. And that gives us $159. So if you look at our quantities here, the standard was chosen and the fabulous packages were chosen. And yeah, this is working right because our binaries, since there's values in both of these, our binaries show a 1 here. And since there's no joyful packages that we sold, there is a 0 here. So yeah, this is working perfectly. Okay, so we are now going to go to part 5. So we'll hold down control, hold down left click, hold control down, let go left click, and we'll copy that tab. We'll change this to May. Okay, so for this part, we are looking to find, we're looking to add a minimum. So let me just add a column here. So minimum, and the numbers they gave us are 100, 100, 50, and 10. So what this means is that if a package is sold, we must sell at least the minimum. So for the standard, we must sell at least 100 in order for this package to be sold. And so for this one, we are going to add a minimum. I'll just call this a minimum constraints. And really, this is like a either or constraints. I believe that's what it was called in the video lessons. Okay. Format painter. And so for the minimum constraints, we're going to go equals quantity minus the minimum times the binary values. Copy this down. And then our labor available, it is now 460, and our balloons are now 400. And we're going to add one more constraint. Add minimum constraints, and this is going to be greater than or equal to 0. Once again, all of this was explained in the video lessons. So I'll say OK, and then solve. And this gives us a profit of $155. And these might look a little funny here, but really these are just, look at 0. Okay, so a final note here. All of these problems can be solved using the standard solver in Excel. There is a free software called OpenSolver that can be found online. And I know that in the past, students have insisted that this OpenSolver software is needed to solve some of the problems in this course. However, as long as the problem is set up appropriately and like the M is like really tight, the standard solver should work just fine.